Alright guys, it's the moment I've been waiting for. Let's tear into this thing and see what's going on inside. So we've just, I've got a couple days of kind of run time on this thing to see how it works. But I've been really eager to take this apart and see what's going on the inside of this thing. So let's get started. So first thing I'm going to do is remove the filter housing. A couple things I wanted to mention that are kind of cool about this. So it does open up on both sides, which not super unique, but it does make it really easy to hose this out, and you can just blow water straight through it. But one feature I do like that I found kind of interesting is the little flap trapdoor check valve things going on inside of here. A lot of pool robots I've seen use little tiny stainless steel springs to keep these check valves closed. This one just uses a stainless steel rod that's heavy, so these are just counterweights, and so you can see gravity just closes those on their own. I like that. You don't have to worry about a spring jamming or getting worn out and breaking, shooting out and getting lost. So pretty simple solution, elegant solution. I like that. All right, set that aside. So I believe all we're going to need to take this thing apart today is a number 2 Phillips head bit. So I'm going to use a drill just to kind of help speed this along. I would recommend that if you use a drill to disassemble or specifically reassemble these things, you go ahead and set the clutch setting on your drill to a low setting, because a lot of these are self-tapping screws that go into plastic, and so you don't want to rip those threads out. And so I like to use this clutch setting here so I can't over torque the screws. Start on the light setting and then work your way up as you feel comfortable. So some of the things I'm really eager to look at with this are the centrifugal pumps. So we're going to tear into this, take a look at the pumps, the drive motor, and then just overall build quality. One thing that's kind of unique about this that I can already tell out of the gate is that it seems like a lot of the components are modular. So if you look in here, you might be able to see this gray kind of control box. And in that gray control box, you'll see a few different connectors on the end of this. So everything's connectorized, which means, I believe, that we can independently replace the motors for both the pumps, the drive motor. It even looks like the LED bar on the front of this thing is a modular kind of independent assembly, which I like to see, because if those things fail, hopefully you can just replace those individually. Whereas a lot of pool robots that I've taken apart in the past, they like to house all of the critical stuff, the pumps, the electronics, everything in one watertight sealed box. And if something goes wrong with that unit, typically they kind of make you replace the entire assembly as one unit. It might also be like a cost savings thing. So anyway, it's nice to see that they've kind of split up some of the more expensive components and made this robot a little more modular. So I'm going to start tearing into this and taking a look at some of the parts and pieces here. So I assume we'll start with these 4 screws on the top. Yeah, nice self-tapping screws. Back right out nicely. And anytime you're doing a project like this, something with a lot of screws, I recommend getting yourself one of these little little plastic ramekin cup things, just to keep all your hardware in. Helps keep everything organized so you don't lose those screws as you're taking this apart. All right, so I've got this upper plate taken off, and it's sliding this cable. I'm gonna try to, oh, I already dropped a screw. I see it. All right, got it. Okay, so this plate comes off, and then that reveals the centrifugal pumps. One thing that's cool to see here is it looks like this cable would be pretty easy to replace. So these 2 fasteners here remove a strain relief. Another 2 fasteners here remove a strain relief here. And then the inside of this cable looks like it threads in with this connector. Let's see if I can get this in an angle that you can see it. There's a connector right in here that you can unscrew and replace the entire cable assembly, which looks pretty cool. I like to see that connectorization. Good solid strain relief here. So this is kind of nice to know that you've got your cable bolted down tightly, because a lot of times people will pull on the cord to pull the pool robot out of the pool. And that's okay to do as long as you don't pull on it super taut. But even if you did pull really hard on this cable, it's nice to know that there's a nice solid strain relief there, so that you're not that tension that you're putting on the cable isn't transferred to the watertight connector, the electronics box. It's also nice to see that there's a little spring-loaded kind of bend support here to keep that cable from making an overly tight bend as it passes through the inside of this robot. So I'm going to slide this up and out of the way. Here are the two pumps. So I mentioned before, a unique feature of this robot is it has dual centrifugal pumps. So both of those statements are kind of unique, at least for the robots I've seen. Dual pumps, a lot of robots I've seen just have one suction pump. This has two independent suction pumps. And then, of course, another unique feature about these is that they are centrifugal pumps and not like a normal impeller style pump. So let's take these apart and see what they look like. I'm already excited to dig into these. It looks like they're Outrunner brushless motors. So pull these screws out. And so far, one thing I'm noticing that I really like to see is that all these fasteners are the same identical fastener. That's pretty cool. So these look like maybe some 304 stainless self-tapping Phillips head screws. They're all the same length, all the same pitch. Makes taking this thing apart so much easier because you don't have to track what specific screw went to what specific hole. Also helps them save some cost on the manufacturing end because there's just fewer SKUs of inventory to have to track when they're building this thing. So if they can use one common screw, they can save a little bit of money. Looks like these screws that hold this bracket to the motor are a little bit smaller. So I'm going to have to grab a smaller Phillips head. This is a number 0 Phillips head here. And that looks to be it. Might be able to get away with a number 1. I think 0 is the call. Yeah, and these are machine screws, so that makes sense because they're tapping into presumably that motor housing. All right, so we've got that little motor mount bracket off. And here is the motor. How do we get this guy out? So I assume we got to pull these screws out, which will let us remove the pump cover. Oh yeah, these are all the same self-tapping fastener. I love this. I love to see this. It just makes life so much easier when taking stuff apart. Okay, so here's the bottom of the pump cover removed. And here is our pump. So, looks like we can pop this cable out of there. This is awesome. So, we can get to each motor independently. Each one has its own little specific cable. So I'm going to reach in here. I may need to go grab a pair of pliers or something. My fingers are a little too big. Nope, here we go. So I'm not sure if you can see in there what I'm doing. Let me hold this up to the camera. There are connectors inside of that, on the end of that gray box. Everything's connectorized. And so I am unscrewing the connector for this specific motor. Piece of cake. There we go. Voila. The motor is out. All right, so it looks like a little 3-pin connector. Again, this thing's kind of wet because I was just using it in the pool not long ago, but nice radial seal. So that's really good. I love to see radial seals in these types of connectors because that way when you slide the connector into its mating connector, it compresses this green O-ring radially, so it's pinching it from the outside. And so that means that this nut really is just there to kind of hold the two halves of the connector together. It's not a face seal where you're relying on compression of the O-ring in this direction to make the seal. So that probably came from some of their ROV underwater robot design experience. That's a legit connector. I like to see that, especially in a completely submerged kind of application. 3-pin connector, so this is definitely a brushless motor, 3-phase wires. And this is an Outrunner brushless motor, so that's a term you'd probably hear in the hobby industry. Basically, that just means that the stator is in this inner portion, and then the outer bell, or the rotor, is what's spinning on the outside of this motor. So you can see the outer housing of this motor spinning. And the rotor's got the magnets, the stator has the windings in the middle. So it's sort of just like a inside-out brushless motor. I do see, looks like metal rolling element bearings, maybe? I'm not sure if these are ceramic bearings or not. What's holding that on there? A little circlip might be holding that bearing onto that shaft. And then the other bearings up top here, yeah, there's a little circlip that holds that bearing in. So ball bearings, I'm not sure if they're ceramic. I would assume they're ceramic. They kind of sound, you hear that? They have a kind of dry sound to them, which makes me think they may be ceramic, and they're shielded to keep out larger debris, but they're not sealed, and that makes sense because this is a totally kind of underwater application, so water is going to get into that bearing no matter what you do. So in this case, it looks like I bet they use ceramic balls inside of a wet bearing housing. Here's the pump impeller. So that is in fact a centrifugal pump. It's going to pull the water in from this direction, and then as the motor's spinning, it's going to sling that water out using centrifugal force into the outer housing. You can see this is kind of the shape of that outer housing, and direct it out the side vents of the robot here. So one on each side. So this is going to be pulling water in through those trap doors I just showed you, these slits in the bottom of the robot. So sucking water in from the bottom of the pool, which is good because that's where all the debris is and all the trash. It's going to pull that water into your filter basket through those little flappy check valve things I pointed out. And then that water is going to have to exit through the kind of inside out flow, exit through the filter media into these, into kind of this central cavity of the pump, or of the robot. And then it gets pulled up through the center of these pumps, swirled around, and shot out the sides. So pretty simple design, kind of, similar strategy to a lot of other pool robots, except this uses centrifugal pumps, uses 2 of them. And it's cool to see brushless motors. These are super simple. They're kind of known to be just intrinsically waterproof as long as all the water windings are sealed. No commutator or anything like that that's got to actually make electrical contact between the stator and the rotor. So pretty cool to see some brushless motors in a waterproof application like this. I think this is also an ROV type inspired design. A lot of electric hydrofoil companies and stuff like that will use this Outrunner brushless motor. So pretty cool. Let's keep digging. So I'm not going to remove that motor. I assume that's just going to be the same exact thing. What is next? So maybe we can go after the drive motor next. So let's take a look at that. So the drive motor is also individually connectorized. So I'm going to go ahead and start by unscrewing the connector. Probably can't see in there with my fat fingers, but the connector comes off nice and easy. Pull that out. Let's take a look at this connector. Oh man, we got a lot of pins in there. So what is that? 7 pin connector. So there's a lot going on in that motor. We'll see if that's brushless. Maybe there's some kind of encoder or some kind of feedback in that thing. We'll see what we're working with. So I think the next move I'm going to make is I'm going to remove this outer track cover here, this gray piece. And to do that, it looks like there's 2 clips on the inside. If I can reach in there. Got 1 clip out. And oh, I'm pushing the wrong way. That's why. Gotta pull that clip inward. There we go. Piece of cake. All right, so we've got that track cover removed. I'll set that aside. Let's take a look in here. So one thing that I like to see on this robot is that they do cover up this track system. So the Nautilus CC, it's got open tracks in here, or this part is exposed. And what I've found is that debris can get caught in these little grooves on the other side of the wheel. And then it gets jammed in there, and it causes the track to jump off this track to jump off the groove of the roller. And I've thrown a track on my Nautilus CC a few times now. You get leaves and debris all up in this area. So it's nice to see that that's relatively sealed. I mean, this isn't like a totally foolproof cover, but it definitely makes it difficult for leaves and other debris to get into this. Also, especially because there's a little planetary gear set here with this drive wheel, even more reason to try to keep trash out of there. So let's go ahead and remove this center wheel. Again, I love it to see the same exact type of self-tapping screw everywhere. And then I assume, oh yeah, there we go. That wheel just comes right off. So here's our track. And then there is the front drive wheel. And then there's a bushing. It looks like it slides in here. So this bushing goes over this post. and then this roller slides inside of that bushing. So that's probably a wear item. This bushing, I imagine, is going to get worn out over time as you get little bits of sand and stuff in there and this thing runs. And then they do key, there's little keyways or little key nubs in this bushing that key into little grooves right here. So that's a nice design feature to intentionally keep the bushing from rotating. So you don't want the bushing to spin on that post, because then you can wear the post out. So they want all the relative motion to happen between this bushing and this wheel. So nice, well thought out design feature there. I think these guys know what they're doing. Let's take a look at, ooh, nice drive gear with a bronze insert there. So this is it's got a double flat shaft here, and then it's got a nice bronze insert on that gear. That's nice to see. That's really going to help with kind of helping this thing resist stripping essentially in the inside of that gear, resist any sort of expansion forces as this gear is loaded and tries to twist on that shaft. So it's going to make sure that that stays nice and tight and doesn't strip out. So cool feature to see there. Pretty nice part. I imagine, I don't know if that's a nylon or what sort of material that is. All right, and then we have these other gears. So this is just a free spinning idler. Let's take a closer look at that and see if there's any kind of bearing, or if that's just, nope. So that just spins on that post, no bushing there. So that's just a free spinning idler. I don't know if we'd expect that to wear out inside of that post much, or if that's, here we go. There's my drag on my drill that I was talking about, so I don't ever tighten these. And then this gear, of course, this is what is supporting this front roller. So if we take, let's go and take this off and just have a look under there. All right, so the front brush is keyed to that roller with the hexagonal shaft. And then I'll set this aside. More of the same fasteners, I love it. All right, and then this is the main drive roller carrier. So that's pretty clever the way that all assembles. You can just remove the drive roller just like that if you need to replace it. And then it is also nice to see a bushing inside of this sleeve to help resist wear. So this may be like a glass-filled nylon part. Pretty rigid. Yeah, that's got some kind of glass fill in it, so that's probably pretty wear resistant. All right, so to get this motor out, I assume it's just as easy as popping out these three guys. I do notice these look like longer self-tappers. Yeah, so these three screws are a little bit longer. So not every screw is the same. So we got to take this bushing out. There it is. Man, this thing is really easy to work on. I love that. So that's our drive motor. That is a geared, so I can tell, I don't want to scar up that shaft, but that is a geared motor. So there's some kind of gearbox in there, which makes sense. I can tell because I can't spin that shaft by hand. So there's some sort of binding going on that's probably just due to a gearbox. I've got a bronze seal, and then I've got some potting here on top of these, presumably screw heads. Heavy motor, solid motor. Cord is potted into the back of this housing. It's a plastic housing, but there's definitely a lot of metal going on in there. And so this is all potted. So this is not a serviceable motor. I imagine you just have to replace the whole thing if it goes out. Pretty nice motor. If you know what's going on with all those pins, feel free to drop that in the comments. My guess is that we've got, let's see, maybe it's a 3-phase brushless motor in there as well, so that would account for 3 of those pins. And then there's possibly some sort of feedback, like a little encoder or something like that, a resolver in the motor itself to give it positional feedback. Could be that there's some kind of torque sensing capability. I'm not really sure. But it appears from the construction of this robot that this motor just makes it go forwards and reverse. That's it. There's no turning functionality built into this. all the turning on this comes from differential thrust between those two centrifugal motors, I believe. So that's a nice part. I like that. Again, so I'm looking at this wheel in more detail. POM is the type of material. So POM is a that's kind of like acetal. So it's kind of like a Delrin polymer. It is recyclable. And on the back side, we got some mold stamps that show you kind of like maybe the date this was punched or some kind of serial number. That kind of helps you keep track of maybe when the part was made or how many shots the mold had on it when this was made. And then you can see these little spots here. These were injector pins. So this was molded. Two halves came together, and then ejector pins pushed that out of the mold, and that's where you get those little circles. Nice part. Injection molding isn't art. It is pretty impressive. There's a lot of design thought that goes into an injection molded part because you have to have draft built into the part. You want all of the portions of your part to have uniform thickness so that you don't get sink marks and stuff like that as the plastic differentially cools in the mold. They've got nice webs in here for some extra support while still keeping thin profiles. And then keeping the part just in general, maintaining thin profiles helps the part cool faster when it's in the mold. And if you can cool the part off more quickly, that means you can pop it out of the mold faster and start the next shot more quickly. So you can increase kind of output with thinner parts. So there's a lot of cost optimization that goes into the design of these molded parts. So solid part, looks nice. I don't know if this is some type of thermoplastic, like a polyurethane or something, or if it's silicone. I've got my soldering iron over here. I'm going to do a quick destructive test. Yeah, it melts. That soldering iron melts right into that. So that is some type of thermoplastic. Not totally sure what. If you're watching at home, don't sniff that. Maybe that is a polyurethane? All right, so we've gone through most of the major components in this thing. We've taken apart one of the drive gearboxes. We've taken apart we checked out the drive motor. And we've taken apart one of these pumps, one of the two centrifugal pumps with brushless motors. God, I really love seeing brushless motors and stuff. That's like, these are just so much more efficient than brush DC motors and have a way longer lifespan because they don't have a commutator to wear out. The trade-off is the electronics that have to drive this are a little more advanced. So that's why these are, haven't made a debut in this type of industry until recent, is because the cost of the switching gear, the control components, has come way down over the last several years. So that's enabled brushless motors to kind of make a debut in products like this. So one thing we haven't taken a look at yet is the control box down here. And so I think to get to this control box, there's just two screws here. So I flip that robot over. I could tighten up my drag a little. Two screws there. Are they the same? Yep, same as the other screws. Love it. And then I'm going to flip this back over. I caught that screw. And now I think our control box, our control box down here is free. However, I do have to undo the electrical connectors. So, I did compare the power supplies between this robot, the Hydro 4, and the Dolphin Nautilus CC. This one's coming in, this power supply, at about 156 watts at 24 volts. So, 156 watts is a couple light bulbs. The Nautilus CC is 120 watts, so not a whole lot less. Maybe 40 watts less. However, the Nautilus CC is at 29 volts, so a little bit higher voltage. That means you don't need quite as much current to move through the wires, but just power to power comparison, 120 watts for the Dolphin, 156 watts for this thing. So this thing does have a little bit, or at least has the capability of having a little bit more power. Okay, there we go. So here's the brains of this thing. So this is the controller. Gotta be sure not to let any water get into these things. Again, I love the modularity of this thing. So controller housing, injection molded part, they put all the stuff in, and then they pot this with a potting compound to seal everything up and keep the water out. I do see a little, that's the end of a capacitor or resistor or something like that popping out of the back. And then we've got, cool, they even injection molded in little labels. I'm not sure if you can see those in the camera. So drive motor, left pump motor, right pump motor, power cord, and then that little LED strip in the front. Pretty cool. And look at all the pins that LED connector has. Man, there's a lot of connections need to be made in that LED. It is like an RGB, so it's got all kinds of different colors and flashes and stuff. Pretty cool. So presumably, if you had kind of a mass failure of the motor system, you may be able to replace this part here, the brains of the thing. So I'm really digging the modularity of this robot. That's pretty cool. And while we have, oops, I'm not making a mess. While we have this off, let's take a look at this roller. So in this case, we have no motor on this side of the track. So I can rotate this a little bit. Yeah. So these are all just idler gears. So there's nothing being driven. These just are idlers. Power is transmitted from the drive motor to this track through the front roller. And then presumably a little bit of that's also probably transmitted through this back roller as well via these belts. So pretty cool, pretty symmetrical setup over here. Super simple. Yeah, super simple design. I like it. What else do we have? So we also have, looks like some ballast back here. So these little stainless steel plugs. Let's see if we can get one of those out and just get an idea for what kind of weight we're talking about. What kind of weight are we talking about here? Yeah, so this is one of, there's a specialty fastener. Kind of a stainless steel slug. It's got a little weight to it, and so presumably that's just to kind of balance this robot out, help it sink when you put it in the pool. Drop that back on there. So there's two of those for some weight. And then in the front we've got some styrofoam up here. So that's kind of interesting. So I bet that's kind of carefully thought out as far as like the buoyancy of this thing goes. Maybe they want it to fall tail first, or maybe that styrofoam just counteracts some of the weight of the heavier components like the motor and pump motors and stuff up here. But that is pretty much all there is to this thing. Pretty simple. We do have one other feature maybe that I didn't talk about that most pool robots have. So there is this rubber flap back here. So this rubber flap comes in behind the rear brush. And the purpose of that is just, I believe, to allow water to drain out of this thing whenever you pull it out of the pool. And so when you're actually running, you've got your filter basket in here. The pumps are sucking water in from these two openings here and pulling a vacuum on this entire inside chamber. And so that's going to draw this rubber flap closed and keep it sealed up. And then when you pull it out of the pool, you lift it up by this front handle. All the water runs back here, and this flap folds back, and it runs out of the bottom to drain. That way, when you pull this out of the pool, you're not carrying 30 pounds of water with you. Pretty cool robot, though. I really like the construction of this thing. I can tell one other detail. So this chassis is polycarbonate. I can see it's got a little PC right here. No, I'm sorry. It's a polycarbonate ABS blend. So that's pretty common for parts like this. Polycarbonate is known for being very impact resistant. ABS is just kind of tough, and so that's sort of like a plastic alloy almost that kind of merges the benefits of all this material. So probably good for drop resistance and stuff like that. Overall, looks nice. I think we've pretty much gotten into every nook and cranny of this thing. There are some covers. So for instance, one thing I've seen in other pool robots, and I think I started to see it here. Yeah. So this is the exhaust vent for the right side pump. So all of the suction water goes shooting out of this vent. And if you see there's already a leaf in there. So debris and stuff can get into these robots past the filter through other little nooks and crannies on these. And I have noticed on my Nautilus that sometimes I'll get a bunch of debris behind that exhaust vent, and it sort of chokes the exhaust flow of this thing. And so if you can't really do much, you can't suck much water into this if you can't get that water out. And so you got to keep an eye on these vents, make sure they don't get plugged up. And I can't, it's not super easily accessible. I could probably reach in there with a screwdriver or something. But it does look like these parts should snap out. Maybe it's a little harder to get to than I'm thinking. Yeah, so this might be kind of tricky to get off. It looks like you'll have to take this whole white piece off somehow with those little snaps before you can get this black vent cover off. On my Nautilus, I actually ended up just cutting out these little louvers, so it's just a straight shot out of the pool robot. That solved that problem. They probably don't do that in this case because they don't want you getting fingers or anything into that pump motor. So that's kind of that grill is sort of a safety feature. But no big deal. We'll see how it works. I'm sure like next time I run this, that leaf will just blow out of this thing. All right. So in summary, I'm pretty impressed with the construction of this thing. This is the first pool robot that I've disassembled where I've seen this kind of degree of modularity. So, we've got separate components for the control system, motor controllers and the brain of the thing. We've got separate components, individual pump motors, drive motor. Everything is modular, and everything has these nice little connectors. And so presumably if some of these were to fail, you could just unplug it and replace just that part, which I love to see. I love to see serviceability in these types of robots. But pretty cool design. These nice connectorized systems, I'm sure, come from their ROV experience in other industries. And yeah, I'm really digging this thing. I think it's really well built. I'm not just saying that. Most of the other robots I've taken apart, like the Polaris, for instance, the drive motor and the pump motor are all integrated into one very expensive kind of motor housing. And so if one of those motors goes out, you're replacing this entire very expensive assembly. I think just the gearbox on that Polaris, which doesn't have any motors in it at all, by the way, one of the track gearboxes is like almost like $250 or $300. So it's cool to see this thing as modular as it is. So hopefully I can remember how to put all this together. One thing I'm going to do as I reassemble this is just make sure that I've got all these connectors really dry because there's some water that was dripping off of this thing as I took it out of the pool recently. So I'm going to make sure I dry those connectors out before I reassemble it. And then one other thing I'm going to do when I reassemble this is just to make sure that I put a little bit of grease on these O-ring seals. So I like to use, this is a very well used tube of vacuum grease, but like a Moly lube or a silicone grease would be good for that application, just to keep those O-rings lubricated so that they make a nice seat in their housing and don't get all twisted up. And that just helps keep that seal watertight. So I'm going to grease up some of these connectors, put all this back together, and then throw this thing back in the pool. I'm looking forward to using this more and more. Looking forward to next summer. Okay, there's one other thing I wanted to mention. So I want to touch back on this control box. I did point out that it looked like there was some kind of capacitor or something like that was hanging out of the potting here. If you can see that, there's an exposed electrical component. And I got to thinking about it more, and I bet you what that is some sort of like capacitive sensor to let you basically know when this thing is underwater. And so I have noticed that when you have this on the pool deck and it's not submerged, I think the front LED bar is like an orange color. And then when you put it into the water, it turns yellow. So there must be some sort of sensing capability that lets this thing know when it's submerged. And I bet you that's a capacitive sensor that they just hung out the end of, they hung out the end of this potting. So pretty clever.